Hello. In this video we're going to talk about some more things about vectors. The size function, how to use indexed for loop access, how to do range for loop access. But first I want to go back and talk about one other way to initialize a vector that I didn't cover in the last video that I meant to. You can also create what's called an initialization list or initializer list. And that's just a list of comma-separated data values that will be automatically stored in the vector. So for example, if I want to store the first 10 integers, 1 through 10, in my vector numbers, then I can write a list like this to get them in there. And I wanted to do this because I want to use, oops, sorry about that. Let's close that off. Didn't mean for that to show up, but I'm going to leave it in. Real world, you know. So I want to use this list in my next demonstrations. So we've initialized a vector, and so we like to know how many elements are in it. And we can do that using a function called size, which I'm going to need for my loops here in a minute. The size function will return the number of elements in a vector. So let's compile and run this program so we can see that. And sure enough, we see that the size of the vector numbers is 10, just as we thought. So that's one of the advantages of vectors over arrays, which we're going to talk about next, is that vectors carry their size around with them, unlike arrays, which do not. So that's how you get the size. Now we're going to use that in our next little example, because I want to demonstrate how to traverse all the elements of a vector. One way to do that is to use the indexed for loop. And I'm also going to show you another way to access array data. Vector data. So we're going to write a for loop that starts at 0. We want it to go up to but not including the last element, the 10th element. Because vector elements are numbered 0 through the last element, we want I to stop before it gets to the actual size. And then we just want to increment I by 1. And then we can use what's called array notation to access each element. So in square brackets, we just put our indexed variable, our loop control variable I, and it's going to display each element. Rather than do a new line though, let's put a space. Okay. So this indexed access should let us show 1 through 10. So let's run that. And there are our vector elements 1 through 10. So that's one way to access the elements of a vector. Another way, though, is to use what's called the range for loop. And the range for loop allows us to not have to worry about the size, as we're going to let it handle that internally. So the way the range for loop works is we're going to declare a variable that's going to store each element of the vector as it is encountered. So what happens is, behind the scenes, the range for loop uses what's called an iterator. And the iterator simply is like a pointer that points at each element. So it's going to point at the first element, the second element, the third element, all the way through. And then when it points at just past the end of the vector, then it knows to stop. But by using the range for loop, we don't have to worry about the size. We don't have to worry about a number I, an indexed or loop control variable. We don't have to worry about any of that. We simply let the compiler handle the movement from element to element behind the scenes. So if I run this, I'll get the very same result. There we go. There are the 10 elements, and I did not have to worry about the size or anything like that. So the general rule is that for situations where you're going to traverse the vector, in other words, go from the beginning of the vector to the end of the vector, then the preferred way to do that is to always use a range for loop rather than an indexed for loop. That way you're just cutting down on any possible errors. So that wraps up this video on some accessing of vectors, and I'll see you in the next one.